This is a video to demonstrate um, the extent of the problems with 41213. The item has been tampered with. During the normal estimate procedure, I make some baseline measurements, and in FM, I noticed, this is the item by the way, in FM I noticed that the output, number one, the left and right channels were reversed. That to me is extremely troubling because that just doesn't happen. That was the first indicator that this was tampered with. Number two, when I was doing the FM measurements, the left channel in mono, first of all, both channels should be equal in mono, but the right channel is down approximately 10 dB from the left channel. Don't forget, they should be equal because it's mono. But what's even worse is that left channel is down, oh, at least 30 or 40 dB from the right channel. Um, Further examination shows that uh, where this is occurring, it's on a board called the FM multiplex board. That board has been removed and some aftermarket board has been put in there. And what I've done is I'm going to send you a copy of the schematic of just the FM multiplex board, which shows all discrete transistors. And then I'm going to show you a picture of this board. We're going to go over and I'm going to show you this. And on this aftermarket board, number one, the board is not even the same material as all the other boards. And I've worked on dozens of these 2230s. I know what's inside. The material is brand new. So this is some aftermarket board that someone put in there and it doesn't work. So anyways, what we're going to do is we're going to measure the left and right signals in FM and show you the difference on two devices. This device is called a dual trace oscilloscope. The upper display will be the left channel, lower display is your right. And to the left of it and above, this device is going to show us in a horizontal graph the actual decibel readings and the difference rather than having to um, take a measurement off the oscilloscope. This actually will do it much more precisely. And pardon the focus. I'm choking. The autofocus is not following the camera very well, but it's a low budget operation. Don't even have a cameraman. Anyway, so I'm going to turn it on. And if I turn the volume up too high, it got a cold. It may make the microphone on this camera distort. But we'll start off and see what happens. Anyway, so here's the item. And I'm going to put it over into auxiliary and feed a sine wave into the auxiliary inputs. And it's actually on right now. I'm going to turn the speakers on so you can hear this. May distort. Okay, so that's what it sounds like. Now we can change the volume as you should, and you'll see the volume change. But what I'm going to do is go back to what's called a dummy load, so I don't have to worry about this microphone shorting. The dummy load, turn this down a little bit. The dummy load puts the exact same stress on the receiver, but converts the sound energy into heat rather than audio. That way I can test items at high volume and not destroy my eardrums. So anyways, let's bring this back. Then I'm going to switch over to dummy loads, and I'll be able to more clearly narrate what we're seeing. So we're going to bring this back. Notice the oscilloscope is changing as I change the volume. Let's bring it back to about there. All right. Now we're back to the dummy loads. And I'm going to change this light a little bit too. Oh, that's nice. Okay, so we're in the auxiliary input, and what we're viewing on the scope is exactly what we should see. There should be very little variance, and if you look at the bar graph up here, there's maybe a 1 or 2 decibel variance, which is within specifications, especially on an item this age. That's nothing wrong, and that's what we're going to use as our reference level. I'm going to go over to FM now, and you're going to see it totally disappear. Okay, so we're going to go to just show you what we're doing here. There's our band switch. We're going over to FM. And what do we have on the scope? It's gone. I'll go back to auxiliary and show you the signal levels on the scope. There they are, exactly what they should be. I'm going to go back to FM. They're not even weak. They're gone. So what I'm going to do is increase the scope gain and show you where those signals are and how much more gain we have to get. First of all, when that bar graph drops the whole range, that's 30 decibels right off the bat. So we already know that the signal is more than 30 decibels weaker. I'm going to amplify the gain of the scope right now. Bingo. I've just added another 20 dB. Wow. I've just added another 20 dB, and now we can see the signal. Yeah, let's do this. That's better. Now we can see the signal, but you still can't hear it. We haven't changed the volume control at all, but that is the signal level. It's down, and again, the upper display is your left channel. So it's down. It's down 30 plus 10. Remember, the whole screen is 30, and we dropped off the bottom of that, so that starts with 30. We have another 10 down from the top. So that's the left channel is 40 decibels down from reference, and the right channel, which is the one below it, is another 10 decibels down. And this is all attributed to this mongrel board that's inside. So I'm going to back this out a little bit, and I'm going to show you what's going on here. And again, the schematic that I'm going to send you shows that there are no integrated circuits on this board. There are just discrete transistors. I'm going to turn the power off because we should never go handle boards inside an item with the power on. So I just turned the power off, and God damn it, I'm going to die from this cold. This top board is what's called the AM-IF board. That's the normal board. If you look at the board material, I need a little pointer here. This normal board material is dark brown. Okay. Now underneath that is where the IF board is mounted. Okay. But if you look, let me get a better pointer here. Yeah, here we go. Sorry about that. Can't afford a cameraman here. But if we look, the board material is like a light grayish, while all the other boards in here are dark brown material. Dark brown. All the boards are dark brown. So this is an aftermarket board. And if we look closely, right here, where are we? Right there is a small integrated circuit. That's 4 pins on the side. And over here is a larger, come on, board. Over here, gotta hire a camera person. Hang on. The lengths I go for, guys. Over here is a much larger integrated circuit. So someone made this board. Oh, and they have these hokey little pieces of tape on here. Here's a piece of tape. Is it showing up? And it says R on it. I'm assuming that means right. Trust me, that did not come from the manufacturer. And look at this. Look at this over here. Look at this. Here's another piece of tape on this board. And the focus is not picking it up, but I'll read it for you. It says pilot. Left arrow is less, right channel is more. And this is all handwritten. And over here is VCO. So this is an aftermarket hack job, technician talk, that has made the item terrible. And it would cost a small fortune for me to reverse engineer this and try to make it right for you. So, I know that video probably is a little shaky and you probably have seasickness now, but this item is been misrepresented, especially if you were not told that aftermarket changes have been made. And this is just beyond economical repair. You should get your money back. So I'm going to pop this back together, send you up the links to these emails, and I feel bad. There we go.